Hello, folks, and welcome to the latest in the No Fluff Just Stuff series of webinars. This week, I'm joined in the virtual studio with Brian Sletten, and we are talking about blockchain. That is the buzzword, perhaps, to end all buzzwords, and it has gotten even more buzzworthiness over the last few weeks as the price of Bitcoin, a blockchain-based currency, has spiked up to $40,000 or $45,000. Of course, in the last 48 hours, it looks like about $200 billion of value has been wiped out of that. But the problem is with all of this is that blockchain seems, or Bitcoin rather, Bitcoin seems to suck out a lot of the oxygen out of the room. And there are some really interesting and potentially revolutionary ideas behind all of this, as well as some amazing implications moving forward that could fundamentally change not only how we build systems, but the entire fabric of the internet. And I don't want to get too deep into all of this for two reasons. One is Brian knows much more about this, and also I want to let Brian drive this conversation a little bit because I know very little, and I'm going to be learning alongside with you. So Brian Sletten, forward-leaning software engineer. One of my favorite quotes about Brian is, and I've seen this come up a couple times, is that Brian must be from the future. And the more that I've had the opportunity to spend time with this fellow, I am convinced that is true. Brian, welcome.
Thank you very much. I wish I were from the future, and if I did, I would bear you glad tidings and everything's great.
Or you are from the future,
and I'm just lying.
we just don't need to know what the future holds right now.
Ignorance is bliss.
Exactly. Well, so we've got Bitcoin, we've got blockchain, and the two seem to get conflated. And I want to kind of get some clarity over these boundaries and some of the underlying ideas, what we're seeing in Bitcoin, what we're seeing in other cryptocurrencies, and really what you see the potential for this. Because as this interest in this area has exploded, I've seen a lot of things from a gold rush for cryptocurrency speculation, but I've seen a lot of companies start up, and it almost feels like blockchain right now remains a solution in search of a problem. So I'm hoping to get some clarity on all of this. But I want to start with this. Brian, what is your background on all of this? How did you get into this? Because you don't strike me as purely a speculator in the currency. What's your story?
You're correct. I am more of a curious wanderer than true believer, but I felt the need for something like Bitcoin before I was exposed to the idea. And these days, I talk about my past life a lot in my talks, in part because they were very formative. So if you've heard me talk about this before, I apologize. But back in 1999, I went to go work for a company called Parabon, and we were building an internet distributed computing company. So if you heard of like SETI at home, that was not notionally like what we were doing, but that was a fixed application that you sent data down to. We were instead allowing you to send arbitrary applications and arbitrary data down to idle computers all over the world. And the idea was that most people do not buy enough computing power to meet their peak usage. They buy some kind of 60, 70 percentile capacity, and then they just saturate it and can't actually solve the problems. And so the idea is that there would be arbitrage opportunities on idle computers that we were going to rent. And, in practice, it worked out extremely well, particularly 20 years ago, given that this was like pre-cloud and even open source J2EE. So we had to build all of our infrastructure by ourselves, all of our failover mechanism, all of our serialization strategies. And so part of the reason why I mention it so much is because it was a formative time. We were doing things that, very few people in the world had ever done before. We were stretching the edge of these new, Java-based platforms. So we had our software running on 8 platforms. So we had 8 separate JVMs, including various flavors of Unix and Windows and Linux and FreeBSD and Mac OS, back then. And you know, the net effect was we had some interesting scientific discoveries. We had people who would take 9 months to run on their own hardware could have their simulations run in a matter of 5 or 6 hours. So there was a certain class of what we refer to as embarrassingly parallel problem that would work really well there. But the thing that just never really worked, and I wasn't really sure how it was going to, was the idea of paying people for their time, the time of their computers. You know, people got stars in their eyes and they thought they were going to get wealthy off of this. But the reality is, you know, we're talking pennies here and there. And eventually we kind of realized, just like a single computer isn't all that interesting, lots of computers together, you know, are potentially very interesting. So we started to imagine payment models where we wouldn't pay you directly. We would pay a recipient on your behalf. So if you've bought things through the Smile program at Amazon, it would be something like that, right? And the idea was there's nobody's going to get rich off of this, but if a lot of people did it, it could generate some serious revenue. And the reason we had to come up with ideas like that is because there was no real mechanism of established payment that would have worked. We either would have had to wait so long to pay anybody to avoid their payments being completely consumed by transaction costs, or you know, just pay them daily or weekly and here's your 3 cents. So there was a fundamental hole, not necessarily in the technical vision, not necessarily in our execution, but in the compensation model that we had. That was really the thing that kind of fell down. And it's not that digital currencies were unknown to us. My boss eventually came to us by way of Cybercash, and they had already gone out of business, which is why he was coming to work with us by the time that we started. So that was 99. And a lot of these ideas go back to, you know, David Chaum's ideas and some of the work that Adam Back and a bunch of other folks, you know, did in terms of proof of work activity and you know, mechanisms for avoiding the double spend. What was different about Bitcoin when Satoshi eventually released the paper was that he also released running software, right? So the actual software paper ideology discussion ultimately kind of grew out of the cypherpunks communities, which is sort of like this mismatch of, you know, techno-utopian libertarian thinking and sort of fear of dystopian realities and whatnot. So when Satoshi eventually, you know, wrote his paper and provided running software, that's really why it took on. It's not that he was necessarily inventing anything. It's just that he synthesized a lot of really interesting ideas into a system that also had an economic model built in. I don't mean that necessarily purely in the currency sense, but in there are incentives to participate and there are incentives against cheating the system. And those incentives will change over time as the dynamics of the community change. And so, you know, he just built all these levers and it was kind of a surprisingly coherent idea at the time. Like whether it's turned out in practice to be that case, I think is not really the case, at least not as he imagined it. But the basic ideas were kind of fascinating, and the fact that there was a running implementation caught people's ideas. So I read that paper and I knew exactly why it was interesting and why it would be useful. Sadly, I did not start mining at the time because then again, there's the idle curiosity, not the true believer. I'd be taking this webinar from my private island if that were the case. But I knew from the beginning that it was going to be something interesting.
And it certainly has been, although not without its challenges. So what there's two things I want to kind of cover on this. One is, can we dive a little deeper into some of the core ideas?
Mm-hmm.
But the other thing that I want to go into beyond there is how have these ideas evolved? Because we've seen competing models with the Ethereum blockchain versus the kind of Bitcoin blockchain, and so I want to dive into those as well. But can you give us at a high level the core ideas in the paper itself? Kind of
Sure.
what is Bitcoin and what is blockchain? Because we're familiar with all these concepts, but I don't know how broadly we've gone into depth in the
Sure.
community.
The fundamental idea behind Bitcoin is the idea of a public, auditable, immutable, decentralized ledger that allows people who don't necessarily trust each other to come to consensus. Right? That's the core of what Bitcoin is. And I think that's also the core of what makes it interesting. It's not it as a currency, certainly, for reasons that I'll explain in just a minute. And I'm not even entirely sure that it serves the purpose of a value store in the same. Given what you said about the value destruction over the last 24 hours, that kind of exposes the lie of the stability of um, the scarcity driving some stability and only forward growth in estimation. But the basic idea is you've got people all over the world who are participating in this community, and they are trying to produce something that will ultimately have a scarcity associated with it. And that largely comes from sort of the Austrian school of economic thinking, about fiat currencies, which all the currencies of the world basically are, which is that governments can make more all the time, and the theory is that when they make more, that necessarily drives up inflation, and that devalues the currency, and therefore sort of punishes people who save money and kind of rewards people who go into debt, because the debt you incur becomes a smaller proportion of asset values over time if there's an inflationary aspect to it. So the idea is, assuming we can create a demand for this digital asset, if there's scarcity baked into it, then as an asset it will grow in value over time, right? Just scarcity drives demand, but that assumes that there is interest in the asset. And so that's sort of the bootstrap problem that Satoshi had. So in order to get investors and just typical people to use this asset or to care about it, he had to have an infrastructure in place. And so the infrastructure required a community of participants who agreed to follow by the rules, but also agreed to check each other in the execution of the rules. So there is a community of people called miners, and a lot of people think the mining is about the actual collection of, you're making money in the mining process, and that's not true. The value that you accrue as a miner is really the incentive for you to do the mining, but the real purpose of the mining is to evaluate the transactions. So everybody is evaluating all the transactions all the time. That way it's difficult for somebody to lie. So the idea is, we come to consensus on what the rules are, we come to consensus of what the current state is, and we come to consensus about how we evolve that understanding. So as people buy and sell stuff, and as stuff is transferred, we still have consensus about what that looks like. And so if we all agree on the rules and the history and the fact that there's value here, then that could be enough to draw interest in the asset. So initially, he had to incentivize the miners to put enough computational power to evaluate the transactions. But then he had to incent them, because otherwise they're just sitting and burning electricity for no reason. And so the idea is, we're minting this asset at a fixed rate, and the people who are involved in the mining periodically will get to assign themselves this new minted currency. And that's their incentive for being involved at the beginning. But because there's going to be scarcity built in, over time there won't be as much mined. So over time we reduce the amount of new Bitcoin that's created periodically, and eventually that's going to fall to nothing, right? There will be no more new Bitcoin created. Therefore, the miners have to have some other incentive to participate, and that's where the transaction fees come in. So to spend something involves, transferring ownership of this digital asset from one account to another, and that is called a transaction. That transaction is validated by the miners, and the miners are able to take, in essence, the change, right? So if you go to a store and you buy something for 75 cents and you give them $1, they give you 25 cents back. With this kind of transaction, you say, I want to send this much asset to this account, and there will be some left over. That's considered the transaction fee. So it's a voluntary amount, but there's clearly an economic model in there where if you allow the miners to take a higher transaction fee, it's more likely they're going to want to include your transaction. Therefore, it's more likely that you will get into the ledger as quickly as possible. So those are the forces. Then the question is, how do we come to consensus? And the basic idea is, if you have some kind of demonstrable stake in the game, you're less likely to be willing to undercut the trust in the system. One of the wry comments that you hear about trustless systems is that they tend to attract people who you shouldn't trust, and that's certainly clear in this world as well. But eventually he chose some ideas, again based on work that several people had done. Sorry, off the top of my head, it's too early in the morning to remember, but there were a couple of researchers who'd done some proof of work research. And so the idea here is, I'm going to sit and solve hard problems that are impossible, as far as we know, to cheat at. So if I actually can demonstrate that I solved the problem, that's a proof that I've got skin in the game, and I'm willing to sit here and burn electricity, which is going to cost me money. So if I'm willing to do that, then I'm less likely to be a cheater or a bad agent, right, in the system.
And so presumably these are like NP problems that you can evaluate quickly but solve over a long period of time.
Right. And so specifically, it is just a collection of hashing algorithms. So hashing algorithms generate fixed size outputs to arbitrary inputs, and they are one-way transformations. So the idea is, let's make everybody look to find an input that satisfies a particular hashing output. And the actual mechanics don't really matter, but in this case, they generate a number and they say, okay, look for something that will generate a hash less than that number. And so it starts off with a very, 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 very big number. So it doesn't take that long to find something that is less than that number. But the idea is, I can't cheat my way to doing it. I have to actually go through the work. So constantly, all these computers all over the world are looking to find a solution to the hash problem. And as soon as one does, they basically raise their hand, oh, me. And they present, in essence, here's the solution to the problem. Everyone else can very quickly verify, yep, that is a solution to the problem. And then they agree, you get to decide what goes into the block. So the consensus is about, how do we decide who gets to decide? And any decision-making process has to have everyone agree on what the rules are. You can't just suddenly say, oh, I don't like these rules anymore. Not referring to anything in particular. But the point is, once we pick who gets to decide what goes into the block, then they look at all the recent transactions that have not yet been written into the block, and they get to decide what things go in the block. So all transactions are advertised to all participants all the time, which should already start to tweak the hairs on the back of, senior engineer's neck. Like, that's a lot of bandwidth, that's a lot of work, that's a lot of storage, right? But that way, it's almost impossible directly to cheat, because if you suddenly say, "Ooh, Michael Carducci just gave me 10 bitcoins," but I'm the only one who's saying that, then everyone else will pretty much just ignore me, right? So once we decide who gets to decide, then you get to put what's in the block, and you get to select the transactions based on the fees. Now, the first transaction that goes in was called the Coinbase fee, and that's the minting process. So that started off, I think, like 50 bitcoins every 10 minutes. So 50 times 30,000 would give you a sense of what you'd be looking at if you'd been involved all back in the day. But then it became halved to 25, then to 12 and a half, right? Then to 6 and a quarter, and eventually that will wear down. But every 10 minutes or so, the node that solves the problem, and everyone agrees solves the problem, gets to decide what goes into the blockchain, but also they get to award themselves the Coinbase fee. So that's how we introduce new Bitcoin into the system at a fixed rate that declines over time. And then you also get the value of the transaction fees that go into the block. Now, you might say, okay, I have the token, right? You have elected me to make this decision. I'm now going to take everything, right? You've given me that power. I'm going to take everything. Well, no, because the system has a cap. You can only put 1 megabyte worth of transactions in the block, right? So each block takes up a certain amount of space. And so in essence, this sort of like caps the greed, because otherwise the miner would be like, yeah, I'll take all the rest of the transactions and all the transaction fees. But this sort of forces you to decide, okay, these are the ones that I want to put in there. And obviously they're going to pick the ones based on the highest transaction fees. So there's now an economic model to keep miners interested, even as the Coinbase transactions decline over time. You still make money on the transaction fees. And then there's an incentive for people to actually provide transaction fees, because if you don't, then there's a good chance that your transactions will be ignored for quite some time. And therefore, it's hard to validate an unverified transaction that's in the distributed ledger. And so each new block is then cryptographically linked to the previous blocks. And so that's where the trust in history comes from. Is you can't go back in time, make a change, and have it validate to the same current state. So there's more complexity to it in terms of like how it chooses which the longest chain of the block. But the basic idea is we have a set of rules, we follow those set of rules, we verify those rules, and periodically somebody gets to decide what goes into it.
So one of the things that I've seen with blockchain is that the power consumption is insane. The most recent statistic that I think is coming from the very end of last year is that currently the blockchain consumes enough power to otherwise fully power a nation with 200 million people in it.
Yeah, so I mean, it's these things change all the time as a function of demand. Demand comes and goes, depend on the asset price. Asset price comes and goes, depending on what people are thinking. So we saw Bitcoin get up to in the 40s. I didn't catch exactly where it went. That was largely driven by concerns of politics, right?
Mm-hmm.
People thought there could be civil war, or there was a coup attempt, and so people are like, I want to get something that is going to give me some economic power in this post-apocalyptic world, kind of ignoring that if society does fall apart, broadband connections and electricity and everything, that's probably going to go away. So good luck trying to spend that. but I think that's what was driving the short term, spike in demand. But that also kind of underlies the larger, I think, sort of fairy tale around the fact that this is only going to go up, right? I'm not saying I don't think it will go up. I think it will continue to go up because we're finding ways where it makes kind of sense for people to engage in this system, but not in the currency sense. And it's in part because of the power consumption, but it's also in part because of the economic incentives. So from the power consumption perspective, I haven't seen anything that I necessarily trust not to be idle speculation about how much is actually done recently, but we know that it's a ridiculously high amount of energy that goes into this. I would say we can't treat that as an externality of Bitcoin and not look at the cost of other financial systems, which includes, all the buildings that all the bankers work in, and all the airplanes that they get on and fly around for meetings to establish regulatory control, and like how do they come to consensus. It's like it's not an apples to apples comparison to just say, oh, we're burning all this on Bitcoin and then not have similar sort of external calculations on the energy costs of conventional financial systems. But it is something that people are very concerned about, particularly when you look at the net effect, which is all of that energy consumption goes through a largely capped transaction rate. Do you have any sense of what Bitcoin is able to do transactionally?
No.
7 transactions per second.
For an individual node or in parallel?
For the system. That's what it ends up amounting to. And when you compare that to other financial systems, PayPal and things like that, I think are in the hundreds of transactions per second. The Visa platform, right, takes payments in tens of thousands of transactions per second. And so it really kind of comes down to, what does all of this decentralization get us? And the answer is a not very efficient, slow public database. So if you're trying to treat this as a database, then you have to recognize the fact that it will have some performance limitations. That's not necessarily a bad thing, right? It's just that it's not a magic. There's a lot of magical thinking that goes into what does all of this mean, and the reality is it produced a system that is not nearly as stable price-wise as the economic theory might suggest. It's a terrible currency because the transaction fees basically only go up. If more and more people use the system, and that's your measure of success, then more and more people are going to be competing to get more and more transactions into the same fixed size block size, right? So that's why there suddenly was interest in expanding the block size a couple years ago, and not everybody agreed to it. So eventually it was expanded to 2 megabytes, and that means we could get more transactions done through at the time. But again, there's just some serious limitations to what's possible, because the idea is that every 10 minutes or so we solve this problem, but computers get faster and more people join the mining pool, therefore our capacity goes up. So that's why the problem gets harder over time. And it's at the point now where a single computer would have to work roughly hundreds of thousands of years to try to find the solution. Obviously, we don't have time to wait for that, so the only real answer is to parallelize this. So we're far past the point where an individual miner at home on a computer could even hope to make any money off of it, right? You're going to be spending more in electricity than you are probably going to earn, but you still can earn, which means if the asset does raise in value, then it's still worth it to some people, right? So that's why there's still a lot of interest in it. There's still a lot of activity, but we've moved away from CPUs to GPUs, which for a while would parallelize the transactions and allow you to do more efficiently. But eventually, GPUs are largely optimized for floating point numbers, and these hashing algorithms are just all integer math. So it was kind of a not a great match. So then people started building FPGAs, and we started to see hardware vendors selling these things. And the value proposition of FPGAs is that you can dynamically write a program to hardware, and in general, it will operate as fast or faster on less power than a general purpose CPU will. And then eventually we've moved to full ASICs, which are write only, like write once, hardware fixed functionality. So you're not going to do this for like general purpose programs, but for something like a hashing algorithm, you can very easily write that to hardware. And so the world of mining these days is really, at least with respect to Bitcoin, is farms of ASICs, and people go in and invest, hundreds of thousands or so of dollars in establishing these farms, and then they sell off hashing capacity. So if you go to one of these mining consortiums, you can say, I want to buy, so many terahashes per second at such and such a rate. And so you basically pay them a fixed rate for fixed hashing power, and you will accumulate whatever hashing power that ends up generating. And, again, the idea is the asset will increase in value. So whatever you spend now, you'll get a higher return on investment moving forward. And if you buy into the theory, then that seems like it's still a decent idea. So the problem is it's a Ponzi scheme, right? And there are lots of places for people to be taken advantage of. I'll say when I did try to mine, the difficulty had already gotten too high. And so the old hardware that I was not using for any other purpose was simply not up to the task. And so it never got anything. It was never awarded anything. And it was very frustrating. So then I learned about these FPGA devices, and I thought, I don't really want to go spend $700 on something like that. So I poked around and I found some on eBay, and I thought, okay, let me try that. So I spent $200 on one, and that's when I learned the important lesson that nobody sells hashing equipment on eBay that still has any value. So, again, there's just all kinds of ways for people to be taken advantage of here, and that's even before we get into the asset bubble aspect of it, which has caused a lot of people to lose a lot of money. So,
yeah, there have been some folks that are late to the game with feeling the FOMO, buying Bitcoin on credit cards, and there are certainly people who did that when it reached $40,000 a week or so ago, and that are very, very unhappy. Although, when you're talking about the cloud ASICs, it reminded me of the California gold rush, that a lot of people went west. A few people made some money, but the people who were did consistently well throughout every gold rush were the people who went out there and sold supplies.
Yeah, and I live in Auburn, California, which is 20 miles from Colma, where gold was discovered, and Auburn thrived in part because it was set up to service the gold miners and sell them shovels and jeans and food and stuff like that. So it's a very good metaphor.
Auburn is in Placer County. Placer being a type of gold that was mined. So I want to move on a little bit because so I understand the basics. I understand sort of the ideas and the flaws of Bitcoin as a currency, but I want to take a step back from cryptocurrency and get back to what are the actual practical applications, because whenever I hear companies talking about blockchain, organizations, salespeople, it just always feels a little sketchy, and often, more often than not, I see blockchain outside of the scope of a cryptocurrency as a solution in search of a problem. So where is this actually having measurable impact outside of wild speculations and Ponzi schemes?
Sure. So again, I'm not purely down on Bitcoin. I think it's an interesting idea. I think it's fascinating that he was able to build all these economic systems in there. It's just not playing out right as a currency, and given the volatility in the price, even as a value store, although it certainly could, right? Bitcoin maximalists believe that Bitcoin is going to head to 100,000 or more over time. And again, just to be clear, the idea there is as it becomes worth more, you can slice it up into finer and finer and finer level of details. So, what might have cost 1 Bitcoin in the past might cost 1,000th of a Bitcoin in the future. So it's an eminently sliceable asset. But I do think the main interesting thing about it is the coming to consensus. And proof of work is not the only one. There's another idea called proof of stake, right? There's a variety of these mechanisms that demonstrate that you've got skin in the game. With the proof of stake, it's like if you invest a certain amount of resources into it, like you maintain a balance of at least a certain size, then again, you're unlikely to want to undercut the trust in the system. And that's a different approach that does not require the idle burning of electricity, but instead, takes a different approach. But it's also an approach that sort of underlies, reinforcing existing imbalances, right? Because you have to have a certain amount to buy into the system. But the blockchain as a general concept is something that we can imagine using in other ways that bring together people who do not necessarily trust each other. And that's what Vitaly Buterin, I can't remember his last name, the guy behind Ethereum, he originally went back to the core developers at Bitcoin and said, right now you're using this Forth-like language called script that does the actual verification. Very limited in what it could do, but mostly check signatures and things like that to make sure that the transactions are valid. He said, if we expand this to be more of a Turing complete language, then we can start to imagine writing arbitrary functionality and run that on the computer. And so they said, no, we're not going to do that. In part because, they have sort of we don't want to upset the economic balances that Satoshi built into the system. And again, we don't know how these things are going to play out. So they were a little concerned about changing the game that much. So Ethereum largely grew out of the unwillingness of the Bitcoin core team to expand the scope of what was possible with Bitcoin. And so that emerged as one of the primary approaches to the smart contract version of this, which is I can define in a contract language arbitrary activities and put those activities into the computer, and those activities can therefore be verified. Everyone can run them. Everyone can verify the same results. And so where that starts to feel like it could be useful, just at a completely trivial but sort of understandable sense, I put together some coursework material for Microsoft on blockchain to help people teach it around the idea of like a Monopoly game. So when you play Monopoly, somebody assumes the role of the banker, right? You trust that person is not going to be taking money under the table for themselves and giving their friends extra hundreds or whatever. So there's a certain amount of trust that you have to put into the person who plays the role of the banker. But in this implementation that I put together, the banker really was just a set of contracts. So the banker was responsible for starting the games. The banker was responsible for registering the players. The banker was responsible for enforcing that only so many people could play, and then you couldn't start playing after the game had started. The banker was responsible for distributing assets to the game players. So again, that's not an incentive to burn lots and lots and lots of electricity so you can play Monopoly, but that gives you a sense of where it seems like it starts to make sense, right? Where if I can put these rule-based systems in place and measure the inputs and verify the outputs, then that's the kind of thing we can start to automate more transactional thinking. And the idea there is you have a marginal effort to deploy to this platform, but you don't have to go to the trouble of building out the entire infrastructure that gives you those capabilities. Just like when you roll out a web application, you are inheriting the architecture of the internet in the process. And so this is one of the reasons why there's so much economic incentive for web-based development, right? It's fast, it's easy to pivot, it's inherently cross-platform. There's no installation costs. You can roll out a new version and reload it just by reloading the browser. There's that kind of idea that a platform that provides a reusable set of services of a generic nature to people who don't necessarily trust each other, but who will agree on the outcomes, that could be the basis of things like notary publics and public records, and just demonstrating that there's been some kind of asset transfer. And so not only are we sort of like thinking about taking the distributed ledger portion out of Bitcoin and imagining new uses for it, we're also creating a platform where, imagine how much effort Uber and Airbnb had to put into to build ubiquitous geographic-based systems that allowed not buyers and sellers, but producers and consumers to meet each other, trust each other, agree upon the rules. You're going to check in on this point. You're going to check out at that point. This is how much I'm going to charge you for. I'm going to pick you up here. I'm going to drop you off there. This is how much I'm going to charge you for. They've largely solved, two of the things that, at least growing up, I was told, don't get in cars with strangers, and don't give people your telephone number or whatever. Now that's how we find each other. They had to invest an awful lot into infrastructure to put that system in place such that people would trust it. The idea is, with a extant decentralized public ledger system like Ethereum, you could disrupt the disruptors, right? There's no reason to have a centralized Airbnb. There's no reason to have a centralized Uber, when you could just have a system that brokered people who had something and people who wanted something, and have that be done in a validatable public kind of way. So I think that's where we start to think that there could be some benefits. Then it comes down to, does the decentralized nature of it actually justify the inefficiencies, right? And I think there are going to be cases that we haven't yet discovered. One of my favorite examples from my work with Microsoft, and it was an example in one of their use cases. Imagine a dairy farmer wants to sell his or her milk to distributors. So they sell the milk, and they're under regulatory guidance in terms of their mechanisms and the quality and the safety of the milk that they produce. And milk is an asset that, if it's not treated properly, will spoil and become completely useless. So if a dairy farmer wants to negotiate with a retail grocery chain or something, they will hire distribution channels to get the milk from the farm to the retailers. And if it shows up and it's bad, then it becomes a question of liability, right? Who's responsible for the spoiled milk? And so Microsoft is imagining, not just in terms of their cloud computing capabilities. So there's just the elastic computation nature of Azure, but blockchains running on there, right, that are public in nature and auditable. But they also are imagining things like the Azure Sphere devices, which are kind of like small GPU powered Raspberry Pi kinds of devices that could be put into things like refrigerated distribution units. And so now you imagine it's a 3-part transaction, right? The dairy farm hands the milk over, the temperature is measured, the humidity or whatever is measured through these devices, and those sensor data elements are then recorded in a transactional kind of way. Then the distributors carry it, from point A to point B, and they maintain temperature sensor readings the entire time. So if there is a disruption in power and the temperature, rises, then suddenly we can say, okay, this is where the milk probably spoiled. And so just imagine like the integration efforts of a centralized system and having to do authorization and authentication checks against writing to back-end systems and validating the results and right? There's just a lot that if we could do this in a lightweight, decentralized, publicly verifiable way, that would provide a lot of value. So I think to the extent that we're going to see some successful uses around these things, it's going to be more in how do we bring arbitrary partners together to do some kind of asset transfer, whether it's a physical asset or a digital asset, and to do so in a way that's lightweight and verifiable. And so again, the public records, marriage certificates, death certificates, certification kinds of things, right? Those, if I don't have to, if you apply to a job and you say that you went to a particular university or got a particular award, if that's something that could be verifiable in a public ledger system, I don't have to track down the phone number of the admissions department or alumni records department to go check to see if you actually went there. Those kinds of things would very naturally be discoverable in a system like this. So again, employment situations, matching people to opportunities, and even just like general asset transfers. Before the pandemic, we were starting to see more and more hotels give you your key on your phone, right? So the idea is I could demonstrate that I am in possession of, in essence, the privilege of unlocking this door under the constraints it will expire Sunday morning when I have to check out, right? So ownership of property or temporary renting of facilities or cars, zip car kinds of things are all, I think, examples of things that might be possible. And so the overall cost of running the thing really starts to get amortized across a lot of different value creation activities. So a lot of people call Bitcoin blockchain 1.0, where the value is currency based. But blockchain 2.0 and beyond is going to start to be more abstract in terms of the value that can be transferred. And so again,
go ahead. Sorry.
And we've seen the emergence of kind of like fun, non-fungible tokens like CryptoKitties and things like that. But you can imagine even like fine art. Suddenly, you go buy a Picasso and the ownership transfers can be recorded. So provenance chains can be established in these sorts of things as well.
So we're getting close to time. We got a few questions coming in, and I'm going to go LIFO just because it's easier for me. So how efficient is verification today? In other words, if I need to verify one transaction out of a billion, how long will that take?
It's mostly just an existence question. Like, does that transaction exist in the chain? If you trust the chain, you don't necessarily have to evaluate the entire thing. So there's one level of verification that just says, hey, can I point to the evidence of this transaction in a trusted block? And that's one of the interesting things with like IPFS, and their linked data model allows you to point into things like individual GitHub commits or blockchain transactions. So now you can imagine sort of more dynamic systems where I say to you, hey, I would like to purchase, you're a photographer, you've taken some kind of photo that I would like to get a license for. So you'd say, great, transfer me some amount of money in a verifiable way. That could be done in a blockchain kind of system. I could point to the transaction and then provide the pointer to you, and you can verify that it had been accepted into a trusted block. So in terms of like how much effort do you want to put into it, it can be relatively lightweight if you simply just want to verify the existence of it. But if you want to make sure that the chain itself is qualified, that's where all the miners are constantly reevaluating the state of things and verifying that there aren't errant blocks or errant transactions in the blocks.
So another question came in. I think this will be an easy one. Won't society still require a backup method for such records? And I'll leave it at that.
No, I mean, it's an excellent point. And I think this is one of the reasons why I don't think Bitcoin, for all the things that are good about it, it has an absolute terrible user experience. In fact, a couple weeks ago, at the latest. Maybe it was even a week ago or two. I don't remember exactly. I tweeted a link to a news story that said 20% of the available Bitcoin has been lost, because it was designed to avoid the opportunity for things like chargebacks. So if you send Bitcoin to the wrong address, good luck getting it back. Whereas most consumers are used to, hey, I bought this thing and they didn't deliver, I want my money back, right? The credit card companies can go back and charge back to the vendors, and the vendors don't like that because they're like, hey, I just made all this money. Oh, crap, you just took some of it back. So vendors like the non-chargeback part of this, but consumers hate it. And given that the level of sophistication that goes into managing Bitcoin wallets, if you do not have backup strategies, you lose your keys, you lose your Bitcoin. There's no recovering. So I mean, there are things like paper wallets and brain wallets and ways of managing this, but the learning curve on it is so much higher than go opening a credit card account or a savings account at a more conventional financial facility. So yes, we do need some kind of mechanism to stop people from losing their assets just because their hard drive crashed or they forgot their password or something stupid like that.
Well, and the perennial story is every time Bitcoin reaches a new high or a new spike, the fellow in the UK whose hard drive containing like 700 Bitcoins in a landfill in Wales, I think, pops up, and I think the current offer is close to $100 million if you dig it up.
Somebody was telling, I don't know if it was you or somebody was telling me recently about somebody who's got an encrypted hard drive that has a fixed number of attempts, right? And if you break the number of, I think it was like a password protected, like an iron key or something. And so he's got his private keys on the iron key. And if you type the password in too many times incorrectly, it basically will just shut down. And so he's only got like a couple of attempts left, and he's got some crazy amount of Bitcoin on there. You can't really get past that consumer inertia, I think.
Oh, and so the clarification, by the way, of the backup question. So is just to clarify, I actually meant backups that didn't depend on technology, electricity, e.g., like paper backup to e-voting.
Right. So you can put print out records of ownership, right? And or records of control of the like your passwords for your accounts, and those can be reified someplace else. But you're going to then have to take those and put those in a safe, like a fireproof safe, because if they're destroyed in a fire or something, then you'd have a problem as well. So yes, the answer is we need some way of capturing and storing evidence of ownership off the chain. But as I indicated, people who are drawn to this for dystopian survival reasons ignore the fact that electricity and broadband networks and things like that are probably not going to be working. And then, there's really no value if you can't verify, because otherwise you're back to what Satoshi was originally trying to solve, which was the double spend problem, right? Digital assets could be handed to two people at the same time, and both of them can try to spend it, but you have no real way of knowing, absent a verifiable set of transactions like this, that you don't have that situation going on.
And we are almost out of time. I want to point one thing out before we wrap up, and that is that if this or any other topic, honestly, is interesting to you, I would highly suggest checking out nofluffjuststuff.com. Not only does it give you access to all of the replays of the previous webinars that we've done, but we also are doing almost daily live instructor-led trainings. And in fact, on February 2nd, Brian is going to be doing a full day live deep dive on this topic to really get into the nuts and bolts of how to leverage this and how to solve some interesting problems with this technology. Certainly, all of these deep dive trainings and half and full day trainings are available a la carte, but there are some great deals to take advantage of right now. in fact, on the very top of the page here, we've got, if I can get my control, we've got the No Fluff Combo Pass. Really incredible deal. $9.50 will get you access to a conference that we've got taking place at the end of this month, and a full year subscription to all of these live trainings. You can, and it's an insane deal. So definitely take advantage of that. We've got team discounts going into 2025. So a lot of opportunities to continue to learn and continue to drink from the fire hose. And also do take advantage of the replays of these free weekly webinars that No Fluff has been doing for quite some time. So definitely check that out. And what I'm going to do, Brian, is I'm going to hand it over to you to give us the last word. But for all the folks who tuned in today, I want to thank you. And I hope you have a wonderful weekend, that you stay healthy and safe.
Yeah, thank you. And I appreciate everybody coming out, and hope to see some of you on the 2nd. Just so you know what we'll do, we'll have some amount of theory and kind of walking through this again, and we'll start with Bitcoin, but we'll then get into Ethereum and Ethereum contract languages and tools like Truffle and Ganache as ways of testing those things out. So you can experiment without spending any money, and then once you get comfortable, maybe move over to the actual Ethereum blockchain. Again, I approach these things from technical reasons, not political reasons. And again, people do things for lots of reasons. These are fundamentally decentralized systems, and I think we need more decentralization in our life. But there's a cost to that decentralization, so it's got to be balanced out to decide whether it makes sense or not.
Awesome. Well, wonderful. Do check that out if you're interested. Check out all of the upcoming trainings. And Brian, thank you, as always, for your time and knowledge.
My pleasure. Stay safe.